Hello, I'm Shelby Howerton, and this is my Physics Lab 3 black hole. The first goal is to find the mass of the black hole using computational methods. The second goal is to use a similar computational model to find an initial velocity that allows the spaceship to fly close to the black hole before exiting the black hole system. The findings from Part 1 and Part 2 of the lab are shown below in the findings section. The key concept of this lab is Newton's second law, which states that the net force acting on an object is the change in momentum divided by the change in time. This equation is related to a velocity update formula, and the velocity update formula is related to the position update formula, as shown. A second key concept is a parallel and perpendicular components of an F force. These components are equivalent to the same components of the change in momentum over the change in time. The parallel component of the net force is parallel to the direction of motion and impacts the change in speed of an object. The perpendicular component of the net force is perpendicular to the direction of motion and impacts the change in the direction of an object. The components of the net force are shown below. The final key concept is the universal law of gravitation, which states that the gravitational force of an object due to another object is an attractive force that's proportional to the masses of the objects divided by the square of the magnitude of the distance. The gravitational force follows Newton's third law, so the force on one mass is equal to the force on the second mass in the opposite direction. The free body diagrams for Part 1 and Part 2 of the lab are shown. In Part 1, the gravitational force on the star is used to find the mass of the black hole. In Part 2, multiple gravitational forces are used to find the initial velocity. The system in Part 1 is the star and the surroundings is black hole. In Part 2, the system is the spaceship and planet, and the surroundings is the black hole. For Part 1 in the lab, the initial conditions of the computational model are shown, including the gravitational constant, the mass of the star, and the change in time. Here are the important equations that are converted to code for the iteration step in Part 1. These include the net force, the parallel and perpendicular components of the force, and the equation to find the mass of the black hole. Here's the iteration step in Part 1 of the lab used to update the net force and position of the star. The mass of the black hole is measured after each iteration. Here are the results of Part 1 of the lab. The mass of the black hole is roughly 2.4 times 10 to the 34 kilograms, which is calculated by finding the average of the black hole mass values from the iteration step. The star follows an elliptical orbit where the magnitude of the gravitational force on the star is less at the farthest point from the black hole from the nearest to the closest point. A possible source of error is rounding values made during each iteration and for the constants, which could explain the different mass values at each iteration. Here are the initial conditions for Part 2 of the lab, which include the mass of the black hole found in Part 1, the initial velocity of the spaceship is unknown, and the trial and error method is used to find the correct initial velocity. The important equations for Part 2 include the distances between the masses, the r-hat values, the gravitational forces, and the net forces. These equations are converted to code for the iteration step. Here's the iteration step of Part 2 of the lab. Importantly, the velocity update formula and the position update formula are also used in this step for update purposes. For the results in Part 2, the initial velocity of the spaceship is negative 4.8 times 10 to the 7th, 2.5 times 10 to the 6th meters per second. The shortest distance between the spaceship and black hole is roughly 2.4 times 10 to the 8 meters. The initial velocity indicates the spaceship moves to the left and up on the screen. Interestingly, the spaceship is shot away from the black hole by the gravitational force of the black hole, which increases the spaceship's speed until the speed exceeds the escape speed. A possible source of error is rounded values for constants during the iteration step, which would underestimate or overestimate the velocity values. The parallel and perpendicular components of the net force are equivalent to the parallel and perpendicular rates of change in momentum by the definition of the net force, which is equivalent to the rate of change in momentum. However, the net force in Part 1 cannot be calculated without knowing the masses of both the black hole and the star, while the rate of change in momentum of the star can be used to find the net force and its components. To test the what-if question, the initial velocity of the spaceship should be less in magnitude in the x direction and greater in magnitude in the y direction. This new initial velocity would allow for the spaceship to orbit around the black hole. This new velocity after trial and error equals negative 1.7 times 10 to the 6th, 1.3 times 10 to the 7th, 0 meters per second, and orbits around the black hole after 90 minutes.